Let's see, how do you graph a linear function in slope-intercept form? Graph y equals 4 by 3x, subtract 2. Let's follow the following steps to make this process easy. Step 1. Identify the y-intercept from the given equation. Look at the given equation. We know that the constant on the right-hand side of the equation in slope-intercept form is the y-intercept. Therefore, y-intercept of this function is -2. Now, step 2, plot a point at the y-intercept on the graph. So find -2 on the y-axis. This is the vertical axis is the y-axis. This point is -1 and this point is -2. You go ahead and plot a point at -2. We are plotting on -2 on y-axis because our y-intercept is -2. Step 3, identify the slope, then find the rise and run. We can identify the slope from the given equation. What is the slope in this equation? We know that the coefficient of x in the function is the slope. Therefore, slope equal to 4 out of 3. And identify rise and run. When you look at this slope, it's a fraction, so it's going to be easier to identify rise and run. The numerator represents how much the graph rised. The denominator represents how much the graph run. So the rise value is 4 and the run value is 3. Now to interpret rise and run, when rise is 4, the graph will travel 4 units up or down. It's either up or down. Up for positive rise and down for negative rise. As we have positive 4 here, our graph will be 4 units up. Similarly, run will be moving towards either left or right. Now look at the sign of the run value. As it is positive, it's definitely right. Okay, so with this information, let's move on to the next step. Step 4 and the final step. Use the slope, that is 4 by 3, to graph the function. How we are going to use this slope is, start at the y-intercept, y equal to -2, and count 3 units to right. So I start counting from -2. I count 3 units to the right. I end up here. Continue to the next point here. Count 4 units up and plot a point. So from this point, count 4 units up. Once you count 4 units up from here, you end up here. So plot the point. This is going to be the next point on the line. Here, if you ask me, can we reverse these two processes? Can I do 4 units up first and 3 units right? And the answer is yes. You can do that. You still will get the same points. Okay. So once you use the slope to plot the new point, you can draw a line through these 2 points. We need at least 2 points to draw a line. Once you have 2 points, you are ready to build your line. But if you want more points, you can use the same pattern, that is 3 units to the right and 4 units up for this function. If you try to build the next point using the pattern 3 units right and 4 units up, the point is going beyond this graph. Okay, so if you got a big grid paper, you can plot more points and then draw the lines. And there is another way. If you want to plot points below the existing point, if you want to plot points below the existing point, you can do that too. What you need to do is, instead of going 3 units to the right, you should go 3 units left. And instead of going 4 units up, you should go 4 units down. So the slope is going to look like this. -4, -3, which is same as, when you simplify this, you will end up with +4/3. Okay, you can rewrite the slope if you want to plot point below the existing point. All right, so now we are ready to build the line connecting these two existing points. You can draw a straight line which is extending infinitely both sides. And you can have the equation on the line, which is y equals 4/3 x subtract 2. So this is our straight line for the function y equals 4/3 x subtract 2. Or this is a line with the slope of 4/3 and the y-intercept of -2. Let's take a quick review. Step 1, identify the y-intercept. Step 2, plot a point at the y-intercept on the graph. Step 3, identify the slope, rise and run. And finally, use the slope to graph the function. Okay. Hope this helps you and you learned how to graph linear functions. And students, think about this question. What if the slope of the function is negative? How will you build the point? If the slope of the function is negative, how will you interpret rise and run?